A HVAC engineer should have a proper understanding of sensible and latent heat to design an air conditioning system. In this recording, we will discuss sensible and latent heat as applicable to air conditioning system. Sensible heat, as the name implies, is sensitive to temperature. That is, adding sensible heat results in increase in temperature and removing sensible heat results in decrease in temperature. Latent means hidden. Latent heat results in change in phase, that is, from solid to liquid or liquid to gas and vice versa. Latent heat will not cause change in temperature. Similarly, sensible heat will not cause change in phase. Sensible heat is calculated by the formula Qs is equal to mCp del T, where Qs is a sensible heat in kilojoule, m is mass in kg, Cp is the specific heat capacity at constant pressure measured in kilojoule per kg Kelvin, del T is the change in temperature. It can be in degree Celsius or degree Kelvin. Latent heat is measured by the formula QL is equal to m into LF or m into LV, where QL is a latent heat in kilojoule, m mass in kg, LF enthalpy of fusion and LV enthalpy of vaporization, both measured in kilojoule per kg. Let us understand sensible and latent heat with a simple example. Water is a common material with three phases: ice, water and water vapor or steam. So let us use water as example. Consider 1 kg of ice at minus 50 degrees Celsius at atmospheric pressure. Let us see what happens when it is continuously heated at constant pressure from ice at minus 50 degrees Celsius to superheated steam at 150 degrees Celsius. In the process, heat added is plotted in x-axis and temperature is plotted in y-axis. When constant heat is added continuously from initial condition of minus 50 degrees Celsius, the temperature of ice gradually increases till it reaches 0 degrees Celsius and remains as ice. There is no change of phase till this point. The heat gained until this stage is sensible heat, as the heat gain causes increase in temperature. The heat gain in the process can be calculated by the formula. So the sensible heat required to increase the temperature of ice from minus 50 degrees Celsius to 0 degrees Celsius is 105.4 kilojoule. When further heat is added, the temperature will not increase. The heat added is utilized to convert ice to water. The temperature remains constant at 0 degrees Celsius till all the ice is converted to water. The heat added to convert ice to water at 0 degrees Celsius is the latent heat. The latent heat to convert ice to water can be calculated from the formula. On further heating, the temperature of water increases steadily till it reaches 100 degrees Celsius and remains as water. There is no change of phase till this point. The sensible heat required to increase the temperature from 0 degrees Celsius to 100 degrees Celsius can again be calculated using the formula. On further heating, the temperature remains constant at 100 degrees Celsius till all the water is converted to vapor. The heat added to convert water to vapor at 100 degrees Celsius is the latent heat. The latent heat can again be calculated using the formula. To summarize, sensible heat required to increase the temperature of ice from minus 50 degrees Celsius to 0 degrees Celsius is 105 kilojoule. The latent heat required to change the phase from ice to water at 0 degrees Celsius is 334 kilojoule. The sensible heat required to increase the temperature from 0 degrees Celsius to 100 degrees Celsius water is 418 kilojoule. And the latent heat required to change water at 100 degrees Celsius to water vapor is 2230 kilojoule. The point to note here is that the latent heat, that is the heat required to change the phase of a material, is much more than sensible heat. The latent heat exchanged during change of phase is very much utilized in the air conditioning system. What is the relevance of sensible and latent heat in air conditioning system? In air conditioning system design, it is important to understand the type of heat gain to the space to select the right equipment. For example, the solar heat gain into the building through windows, wall and roof is sensible heat. The people in the building add both sensible and latent heat. Hence, the cooling coil has to be selected to remove the sensible heat and dehumidify the water vapor from the space. The evaporator in the AC equipment removes heat from the space by changing the phase of refrigerant from liquid to vapor. That is the reason it is called as evaporator. Latent heat of vaporization of the refrigerant is utilized to cool the space. Warm and moist air enters the evaporator at 24 degrees Celsius and leaves at 12 degrees Celsius. The sensible heat of the space is removed by change in temperature, that is from 24 degrees Celsius to 12 degrees Celsius, while the latent heat of the space is removed by condensation of the water vapor. Air conditioning equipment removes heat from the space mostly by latent heat. In a typical AC evaporator, refrigerant in vapor liquid mixture enters at 7 degrees Celsius, removes the heat from the space and leaves as vapor at 7 degrees Celsius. The condenser in AC equipment rejects heat from refrigerant to atmosphere by changing the phase of refrigerant from vapor to liquid. That is the reason it is called as condenser. In a typical air conditioning condenser, refrigerant in vapor state enters at 60 degrees Celsius. It is cooled by ambient air at 46 degrees Celsius and leaves as a liquid at 60 degrees Celsius or lesser. It has to be noted that all the numbers used in the presentation are only representative values. The numbers may change based on various design and operational conditions. You will have a better understanding of this when we discuss refrigeration cycle in the next module. Thanks for your attention. In the next module, we will discuss refrigeration cycle and various types of air conditioning systems. Thank you very much.